In this first example, we need to start with finding a common denominator. So I'm going to leave the whole number parts alone and just work with the fraction parts. So between 12 and 5, if I count up my multiples of 12, I know that 12 and 5 both go into 60. I can also figure this out by multiplying 12 times 5. Now, the first fraction got multiplied by 5 in the denominator, so it's going to also get multiplied by 5 in the numerator. That gives me 35. The second fraction got multiplied by 12 on the denominator, so it needs to get multiplied by 12 in the numerator. So that would be 48. Now I can add the whole number parts and the fraction parts separately. So if I do 2 plus 4, that's going to give me 6. Fraction addition, the denominator is going to stay the same. And then 35 plus 48, which will give me 83. Now, you notice that 83 is bigger than the denominator. If this was a fraction alone, that wouldn't be a big deal, but as it's a mixed number, that is a problem. So we need to take the fraction part and take out another whole. So every 60, I get one whole. So if I look at my number 83, I've got one whole plus an additional, well, let's find out. 83 minus one whole, 23 left over. So I can take 23 away from that, I can take that 60 away from 83 to make this 7 wholes. And then I've got 23 left over out of 60. And that is going to be my answer. Let's go on to example 2. In example 2, I'm in a similar situation where I have unlike denominators. So let me find a common denominator first and then see where that leaves me. Well, I know that a common denominator for 2 and 4 will be 4. So the first fraction gets multiplied by 2 in the denominator, so times 2 in the numerator. The second fraction is already 4, so I'm going to just change that to be, I'm going to leave it alone. Here I run into a problem. My problem here is that 2 minus 3 would give me a negative number, which is fine normally, but it's not fine when I have improper fractions, because the 6 minus 3 isn't going to give me a negative number. So I can't have it both ways. The way around this is two ways. The first way, I'm going to change the 6 and 2/4 into an improper fraction. 4 times 6 is 24, plus 2 is 26, minus 3 times 4 is 12, plus 3 is 15. Now I can subtract. 26 minus 15 equals 11 over 4. So I can leave my answer as 11/4, or I can change it back into a mixed number. 4 goes into 11 2 times with a remainder of 3. My other option, if going back up to this step right here, my other option is to borrow. In other words, this first fraction, which has 6 and 2/4, I can steal from that 6 and make it 5, and I get to add 4/4 to my numerator. So that's 6/4 minus 3 and 3/4. Well, now I can subtract like normal. 5 minus 3 is 2. Fourths stay the same. And 6 minus 3 is 3. And notice, both ways give me the same answer. Now for the last example. The last example has 3 fractions with 3 different denominators. Well, if I want to add them, I need to find a common denominator for all of them. 3 goes into 6 already, but 5 doesn't. So if I think about what's going to get all 3 of these, well, 6 times 5 is 30. That will also work for 3. 6 times 5 is 30. 3 will go into 30. So let me change all 3 of these to have 30 in the denominator. The first fraction gets multiplied by 6 in the denominator to make it 30, so I'm going to do 6 in the numerator to make it 18. The second fraction gets multiplied by 5 in the denominator to make it 30, so it's going to get multiplied by 5 in the numerator. And then the last fraction gets multiplied by 10 in the denominator to make it 30, so it's going to get multiplied by 10 in the numerator to make it 20. Now, the denominator will stay the same, just as if there were just 2. And on the top, I'm going to add 18 plus 5 plus 20. Well, 18 plus 5 will give me 23. And 23 plus 20 will give me 43. So again, I have 43 thirtieths as a fine answer. And then if I want to change that into improper fractions, there's 1 30 in 43. That is, 30 will go into 43 one time with a remainder of 13.